This video will explain how to determine the algebraic model for 2b. In order to determine the algebraic model, we need to be familiar with the key points this time for sine. Let's look at our base sine function. Here's our base sine function. There are 5 key points that we want to be familiar with. If we focus on one wave or one cycle for the sine function between 0 and 360 degrees, there are 5 key points that we want to note. The beginning of the cycle starts at 0, 0, but there are 2 other intercepts that occur halfway between the beginning and the end of the cycle and the end of the cycle. These are all at the exact same y values as the beginning of the cycle. So we have 0, 0, 180, 0, and 360, 0. We have a maximum occurring halfway between the beginning and the midpoint of the cycle. The maximum is 1 at 90 degrees. We have a minimum occurring halfway between the halfway point of the cycle and the end of the cycle. The minimum is -1 at 270 degrees. Again, we want to be familiar with the general shape of our sine curve. So it goes up to a max, down toward the min, and finishes it where it started, and the 5 key points for sine. Let's return to our graph. Now, where do we see the start and end of a sine cycle? One possible location is right here. If this is the beginning of our sine cycle, then the end of it will be right here. Notice we have our max halfway between the beginning and the halfway point of the cycle, and our min halfway between the halfway point of the cycle and the end of the cycle. Now, what are the transformations that took our base sine function and moved it to this location? Recall that the beginning of the sine function is 0, 0. So this has been moved 30, 60, 90, 120, 150, 180 degrees to the left, and down 1 unit. So the transformed sine function would look like this. Plus 180, so we can move it to the left 180 degrees, and minus 1 to shift it down 1 unit. Let's check to see how well we've matched this graph by graphing this using any graphing technology. Here we are in Desmos. I'm going to graph our answer. So sine x minus 180 to shift it to the left 180 degrees, plus 180 to shift it to the left 180, and minus 1 to shift it down 1 unit. Now there's something wrong here. Let's look at this graph. Does it match what we want? Let's take a look at the graph we're trying to match again. You can see that the maximum is actually at 1 and the minimum is at -3. Here in our graph, the maximum's at 0 and the minimum's at -2. So something's not quite right. How can we get the maximum to actually go up to 1 and the minimum down to -3? What else needs to be changed? Well, after some thought, recall that the amplitude is the difference between the maximum and the minimum divided by 2. So if we look back at our graph, the maximum is 1, the minimum is -3, which is a total of 4. When we divide that by 2, we get 2. So the amplitude of this graph is in fact 2. So there's something missing from our algebraic model. We need to add something in here. the function should be 2 times sine x plus 180 minus 1. Again, we have an amplitude of 2. Let's go back to our graph and make that change and see how well we've done. I'm going to add a 2 in front of the sine, and there we have it. You can see that the maximum now goes up to 1 and the minimum extends down to -3. We've matched the graphical model that we were trying to match.